And I'm live. That is pretty cool. Today is 11th of November. So that is 11/11, 2025, Tuesday. And let's begin. We will do some crazy stuff today. Yesterday we saw how to implement DDA, which is Digital Differential Analyzer. And today, shit, we will apply that to our game, to the actual thing that we have to apply it to. And shit, what is 86 into 17? That would be 860 plus 7, 8, 560, 560 plus 42, 602, 602 plus 860, 1462. This might, I don't know. Okay, that is correct. That is correct. Okay, Pmax skill server, Pmax set, attach, target is game and shit. Okay, 7,100. 7,100 minus 7 into 7, 490 plus 7, 490. 7, which is 500 plus 3 minus 500, 6,590, 6,500, 6,603. Shit, shit. Okay, that is correct. That is correct. That is cool. And let's see. Get a status, and we are behind. So first I have to sync my main branch with the main fork. Yep. Update branch. Yep. So yes, 2 hours ago, successful. Okay, so we have everything, and in my main branch I can just git pull origin main and shit. Git remote. It is called origin, but why the error? Git pull main shell. Git pull shell. You cannot pull with rebase. You have unstaged changes. Please stash them or commit them. Git switch and DBA. Yeah, and everything is not committed. Git add all of this and git commit local and git switch main git pull and git status. Everything is up to date, so that is nice. And we have bloom.fs, which is quite a bit of stuff, and helper. Okay, cool. And let's compile and see how this runs now. That is easy. Okay, and yes, we might actually be wrong, so it has to process. Wait. Yeah, make unable to open output cmake main cpp build remake 5 dot o dot slash remake 5 dot os6 and gmake cd back remake this and make and successful, and target is my game, which is right here, and this is the current state of the game, and that is kind of cool. So yes, shit, that is cool. Oh shit, this is not stopping. This is not stopping. Literally, this is Q to quit. Enter. to put random cells throughout the grid, and S to edit grid. But S is not working right now. Okay, so we have to do something. And space does not stops the game. That is also crazy. And R does clear the grid. And yeah, so the thing that we have to work on, and shade. This is like very slow. Look at this. Yeah, we need DDA. Is the FPS not good? Source main.cpp FPS is FPS, and okay, and that is 100. So 100 should be good, but it is not very good. Something is not adding up. Render prediction grid. Whenever we are in this update function, render grid, this will be called by handle all inputs. Okay, that is something. And change cell is also something. On random and draw help dialog boxes function, and okay, sure. Begin drawing. Take input was supposed to be a function. Begin texture render grid handle all inputs. Okay, if game state equals what? Okay, shit, we have to read this code. There have been changes in the code base, so we have to like understand what happened. We're including a bunch of stuff, libraries, if defined platform desktop, then define GLS version 330, else platform Android. Okay, why do we have platform specific code here? Somehow we do have. And then screen width, screen height, that is nice. Init window, that is also cool. Then grid and prediction grid, that is also cool. Rows and columns, rate initially is 1, game state is 2. And here we have said 1 means start, 2 means pause, and 0 means stop. So there is a difference between pause and stop. Okay. And set target FPS. Bloom is a shader thing, which I don't know right now. And GLSL is a shader thing. Okay. Load render texture. Load render texture. Okay. And screen width and screen height. These are the dimensions for the texture, and this is a render 2D texture. Okay, and why do we need the render bar in a texture? But okay, time equals 0. That is, yes, a little bit of my contribution there. And begin draw. Okay, we are immediately beginning to draw, and then texture mode, target, begin texture mode, and render grid, handle all inputs. Okay, and if game state equals 1, which is start, then time plus get time frame, and if it ever gets bigger, then update the map. Otherwise, and yes, and else if game state equals 2, which means pause, then still increase time and still update, but update the prediction grid in that case. Okay, that does make sense. And then render prediction grid. Okay, and texture, begin shader mode, bloom, draw, texture, rectangle, that is target.texture. Then this is a function which takes in, which needs texture 2D texture and a rectangle, source rectangle, which will have details about the rectangle, then the position of the rectangle, and then the color. Okay, and yes, shade. Okay, here we are converting this thing into a rectangle. Okay, and this is 0 0, that is the starting location of the rectangle. Uh, yes. Wait, what things does a rectangle take? Rectangle has four components, and what are those four components? Those four components are x, y coordinates and width and height. That is nice. So x, y coordinates are top left. That is nice. And then width would be texture dot width, which is the width of the whole screen, and draw texture rectangle. Okay, so we have our whole thing. We draw everything on top of it, and on top of the our whole thing, we are drawing a texture. That does make sense. And end shader mode, then update dialog box, and then end drawing. So where is the update position? It is here, handle all inputs, and here we have our main grid, our prediction grid, and game state integer reference is the thing that we are taking. Okay, and then rate. If key pressed, F game state, make game state equal to 1. That makes sense. And if is key pressed, key P, if we press P, that means the game will pause, because 2 means pause here, and prediction grid equals grid makes sense. And if key press is quit, then game state is 0 and we uh, exit the game. And if mouse button down is left and game state is 2, that is pause, then we make prediction grid equal to grid, right? And change cell in grid 1 and prediction grid 1. In both the things, we are changing the cell. If the game state is 2, if left button is down, and if right button is down, then we are making the cell by taking the position of the mouse. This is kind of not very cool. A function to take in grid position using mouse position and change it to the desired state. Okay, shit. This does not look very cool. Yo, TS coding is cool. Shit, TS coding is cool. Yeah, and some people call him Soding. I don't know why. And mm, a friend of mine said that he looks like an egg, Mr. TS Soding. And yes, he has his own visualizer and stuff. He is a scary person. Vector 2 location, get mouse. Okay, so there we are handling the game state, the main okay, the game can be in two states. Yeah, the game can be in multiple states. And shit. Yeah, the game can be in multiple states. One is the actual running state, when we have given in the patterns which must run, and the second is a edit state, in which we are editing the pattern that we see on the screen. And shit, the problem that we are doing right now, I think, and I think it is a problem, is that both of these states are being handled in a single loop, a single loop, and that does not look good. That does not look good. That is introducing latency, because we need, whenever we are in this update state, we need the loop to run faster. Right, we need the loop to run faster for this edit state, and all of this pre-calculating. And so the problem is, we have a single while loop, and this while loop in every iteration checks if we are in the run state or if we are in the edit state. And this is kind of introducing quite a bit of overhead before actually getting something on the screen. And dot slash my game. This is like very slow. This is very slow. Maybe this is because of 60 FPS. Let's see. Uh, because the yeah FPS is 100. Yeah, this would not help in the FPS. Big, yeah, yeah. So we a new thread, a separate thread, which will keep track of the mouse position and keep updating the cells that the mouse is passing over. But this is, I don't even know how we would spawn up a thread if we have a single while loop, because in a single while loop we are deciding every time whether are we in the running state or in the edited state. So what I will do right now is I will have to separate out these two modes, edit and run, and these will be our like high level modes. And in the running mode there can be pause, where we are just pausing the thing and we are not editing anything, like just to admire what we have on the screen. And in the edit state we can have two modes. One is pure editing state where we just edit stuff, and one would be prediction mode, in which if we press whatever the key map would be, if we enable the prediction mode, then we will see if we do go forward with this pattern that we have edited on the screen right now, what would be the result that we see. So yes, that would be nice. Let's write this down. You will have a run state and a edit state, and run state would have pause, actual running mode, and pause mode. And edit state would have a like normal edit where we are just editing cells, and the other would be this prediction mode where we are predicting what the final output would be if we do go forward with this edit state. Okay. And shit, why do we just render grid? We are rendering grid and handle all inputs. Cool. If if right, begin drawing, begin texture, and begin texture mode. How many begin things do we have? We have begin texture, begin shader. Okay, these are the three beginning things that we have. And then here we have begin end texture mode. So texture mode starts from here and ends there. And in the shader mode, yeah, shader mode makes sense. We are putting shader. So what is the texture mode actually enabling us to do? Begin texture. We are doing all of this stuff, prediction grid and all that crazy stuff. And begin input is all handle input is also handling something. And right, load shader from GLS version. Let's go there, and it has been defined here. It is a platform which has been okay. Oh, GLSL version for textures. That is something. Hello, chilled Nick. It's with hello. How is everything going on? 130, and we have 100 and 330. OpenGL. Okay, GL makes sense. SL shader library corresponding to OpenGL 3 plus, introducing in and out keywords for shaders. We are just changing this variable. Okay, whatever it is. Okay, we have two grids. That is fine. Then we have rate and game state. Okay, we can do better than having a game state like this. We can have enum or something. Enum for game state, where we will have start and pause. But I guess uh, since we want something like this, a high level run mode and a high level edit mode, we don't even need to have a game state because we will have a separate while loop which has everything to do with the run state, and a separate while loop which will keep track of everything in the edit state. Right. So we don't even need uh, a game state because we will know where we are in the loop, and whenever user switches we will just point to the other while loop. Okay, and in our main file we will have this thing as our main function in the main function, and this will call this other while loop for the edit state whenever the user wants to go in the edit state. That makes sense. Yo, I am good. How are you doing? Yes, I am also doing amazing. Just clocked in right now. What are you building today? Today we are building Game of Life, and the main purpose is right now if we run this, this is the problem. If I move my mouse too quickly, then I'm not getting too much precision. All of these cells are not getting updated in the middle of the mouse position. Like, look at this. So yesterday we went through and we did quite a bit of mathematics research, and we made this thing. So here we have this two coordinates. One is blue one, which is moving with the mouse, and the other is red one, which is moving through the keyboard keys. And so we have these two coordinates, which are like analogous to the two mouse cursor positions that we get. And we are all of these green dots in the middle. This is a path created by choosing one of these points as the starting point and the other one as the end point, and we are predicting or going through this path and seeing in our game of life, we will see whatever cells this line is passing through, and we will light up all of those cells. That makes sense. And also, if you say that what if we draw a circle, right? But since our FPS mouse position is getting updating fast enough so that we can treat this whole circle as like a bunch of straight lines, just like kind of differentiation, the same thing. And yeah, we will be able to approximate a circle or whatever the thing is that we are trying to approximate. And yo, hello, and 1499. Yes, it is interesting. And this program, this looks like really cool because here we, I mean, this, all of this data on the top, the precision of the blue ball, red ball, delta X, delta Y, and slope and everything, source. Yes, here, if you look at this, here blue ball is the source, right? Source coordinates and the coordinates of the blue ball are the same, and the target and the red ball are the same. But if I were to like swap these two balls on their x coordinates, then they will change. Now, if you see, red ball is the source and the blue ball is the target. So yeah, I'm choosing depending on their x position which ball I'm choosing as the source and the target. So that is cool. And then we also have the slope here. And there was one thing that I like kept getting wrong repeatedly because the origin is not here on the bottom left. The origin is here on the screen on the top. So for x, for any given point, the x is normally calculated as we do normally from left to right, but y is not from bottom to top. Y is this from top to bottom. Yeah, so yeah, I kept messing this thing up for calculating the new location. And also this division thing. Right now, I have divided this whole green line into two divisions, and if I increase this, so this is just dividing the line into multiple divisions, kind of like, yeah, a practice exercise. So this is what we did yesterday, and this was like so cool, really cool. Look at this, and now it just works. Yeah, so this is cool. And another thing that we did yesterday was evil and a granny thing. Here we have a granny, and these circles are her eyes, and they always follow this blue ball, and they look all wonky because I don't know why, because human eyes do not move like this. But yeah, they are simulating actual human eyes, so that is cool. Look at this. They are always following this blue ball, and they are not getting out of this red circle, so that is cool. And we had to use Pythagoras and stuff here. And yeah, that's cool. And back to this. Here we have to do the precision thing. Lovely. Holy shit. Yes, that is cool. Granny weird load. Yep. But interesting. Yeah. Granny is cool. And I wonder how actually human eyes move, because yes, there is also the fact that human eyes work in 3 dimension and not just 2 dimension like this, like a pendulum. So yeah, that is also why they look wonky. Okay, and yes, here we have a problem because we have a single while loop for both the states of the game, which is the run state and the edit state. I want to have separate while loops for both of them, because in the edit while loop I need more precision for the mouse, and also I need a separate thread which will keep getting the mouse position and keep updating the grid, and the rendering part for the grid can go on slowly at 60 fps. So yeah, we don't need this uh, game state because we will have two while loops. Vector, okay, we will have two grids. Game state we can remove, but we will in a while. Take grid position. Yes, that was the function that I created. My bad. Got removed by the maintainer, my friend. And auto bloom, which is a shader, bloom shader. Okay. And render 2D texture target, which we are calling target. Okay, so okay, why do we need this texture? I don't get why we need texture. Begin drawing texture, and we also have end. Okay, shit, we need the texture here for the shader. Okay, okay, that does make sense. Begin texture draw mode, and but we are doing that inside the shader mode, so I guess this should still make sense. Okay, something is lost. Yes, we don't have the texture anymore. Shit. Shit, yes, we lost the texture. We lost the texture. We have to bring that back. My game, and yo, yes, let's go. And reset. And let's have 1, 2, 3. 1, 2, 3, 4, 3, 1 here, 1 here, and there's 1 here, and then I guess we have to have one cell here. And then we can start. Shit, no, I messed up. 2, 3. I'm trying to make a fish. This, this, and this, I think. Shit, okay, I again messed up. Okay, that is not the point. Yeah. Begin drawing and texture. Okay, shit, all of this handle input has to happen before we do anything. Update map, get frame. Okay, handle on inputs. And if game state equals to something, and in both the things, we are updating the time variable. Render prediction grid. Yeah, that will also go away. And okay, all of this will go here, and it's handle input, and here we are managing the time for updating the map. And cool, for updating the map, and then we won't check the game position. Right, this is cool, and you would suppose only running this loop only runs the run, like run mode. Right, that is cool. So yeah, this loop will only run the run mode, and here we are updating the map. If we have passed enough time, then begin drawing, begin texture mode, render grid, end texture mode, begin shader, draw the shader, and update that. That is clean. And then handle all inputs. We will handle all the inputs. Handle all inputs, and cool. Okay. We have the grid, the main grid, the game state, and the rate. We don't need the game state. Yes, we do not need the game state. We do not need the game state. And if whenever we press forward, we don't even need to check the forward. We are supposing that we are calling this handle input function, handle run input, handle run inputs, and we don't need to check for if. We will check for pause, and whenever pause, shit, yes, that is one thing that we need to keep track of, whether we have paused the game or not. And for that, I guess enum would be much better. Enum, enum state, and running, or shit, why? Yeah, enum is fine. I thought maybe we can use a single boolean, but this checks out. Shit, definition. We are using pause for something else. We can use a bool value, game state equals, okay, or running equals true initially. Okay, handle not all inputs, but run inputs, and go to that function, and this will not take all of this stuff. This will not take all of this stuff. This will take running, because yes, that is the only thing that we need to know about. And we can add it here, a bool reference running. Okay, so if key pressed, then running equals false, and if q, then I guess I did create a function for exiting the whole game, and it is lost, kind of. Change cell for exiting. We can just return, or can we exit directly from this without, yeah, without, can we exit directly? I guess yes, we can exit directly. There is nothing that we want to like keep keep before exiting. Yeah, we don't need to keep track of anything. So quit. This won't take anything. This will just do close window and exit 0. Good. And yep, all of this mouse related stuff would happen later, not here. And yes, shit, rate is also something that this function would need. So yeah, this is an integer reference called rate. Right, so that we can update the rate, and all of this mouse related stuff would happen in the edit mode function. Edit mode, yes, edit mode. And shit, since the prediction grid only needs to be known in the edit mode, we can limit the scope of that second prediction grid, if that makes sense. Hello, why the whole code is on file? Cannot we split it? It's so easier to code and debug. Uh, we have like 2 files, and right now I don't actually know. I mean, we are 3 friends working on this, and we don't actually know how to like make this more better, and like how to increase the standards. So first of all, we will just make this running, and then we can split. Right now we just have 3 files. Yes, main, helper, and one for variables. That is all we have right now. And edit mode. Shit, I messed up. The mouse related data will go there. And game state, yes, we don't need the game state. Game state equals true, and fill everything with zeros. Okay, all of this is slow. Yeah, enter key. Yes, enter key. Spawn random cells throughout, and R for resetting the whole thing. Fill all the grids with 0. That actually looks good, right? And we don't need the prediction grid, at least not here. And we can remove the concept of prediction grid from here also. We just are sending the grid, running or not, and then the rate. Shit, this looks clean. This actually looks clean. Okay, and here for the mouse, whenever we are in the edit mode, we will have our own thing. We will have our own thing, and yeah, we will have our own thing. Do we keep this edit mode function in the helper functions, or yeah, we can keep this edit mode function in the helper functions? Makes sense. It becomes quite messy. Yes, it is becoming quite messy. So what about the thing you were doing yesterday, the circle and the line? Yes, now we are going to implement it. Right now I fixed a little bit of code. We had a single while loop for the running state and the edit state, and the problem was whenever that while loop was running, we were checking whether we are in the running state or we are in the edit state, and re- rendering stuff on the screen accordingly. But what I have done now is we have a separate while loop for the running state, so that whenever this while loop is running, we know that we are in the running state. So we already know what we have to render. We are just rendering. And whenever we are in the edit state, the state in which we can click on cells and change cells, we know what we need. And we also know that we need to take the cursor position, which we can. The process of taking cursor position and updating cells on the grid, we can offload that to a separate thread, and this is easier to put on a thread because we know the lifetime of the thread. That thread will run as long as we are in this while loop for the edit mode. But when there was this singular while loop for both the states, we didn't know how to, like, till how long do we want this thread to go on, and yeah, when should the thread update the state and when not. So yeah, this looks cool. While not, window should close, and I'm getting a phone somehow. And yeah, cool. Put my laptop on charge. That would be nice. Cool. While window should close, in the edit mode, we need to take mouse position, and we don't need to check game state because we know we are in the edit mode. So that is nice. And prediction grid. Yes, prediction grid is something that is just known to the edit mode. So yeah, the lifetime of the prediction grid is just here. Standard vector of standard vector, and okay, what we need is this thing will take std vector of integer reference the main grid, and we'll say auto prediction grid equals the main grid at the start. And here we will add, if someone says that they want to go into the edit mode, for which I guess we can keep the key as S for, I don't know, I guess S for change, quit, continue, pause. Yeah, different things. Yeah, I guess nothing was depending on that. Yep, P for running equals false. We just stop and nothing happens. Right. And Q for quit, key down for decreasing the rate, key up for increasing the rate, and R for filling, for removing everything, and enter for, yeah, for putting on new cells. That is nice. And handle input. And we are only doing this. We should only be doing this when we are not in pause. state and running while the game is running, and we have passed enough time. This looks cool. Okay, and update map function, that is nice. And here we have our prediction grid. And yes, here, yes, all of this mouse thing, and then begin drawing. What will we draw? Right, we'll write a separate function, void, this won't return anything, and handle cursor, let's call it, and it handles all mouse related stuff. Okay, we can remove this step. This thing just needs the main grid, vector standard, vectors, int, reference grid, and prediction grid. Don't change stuff in the prediction grid. Don't change stuff in the prediction grid. Okay, and what do we want? We want this function to run on a separate thread while, and yes, this thing also has two modes. Edit mode has a normal, no, share. No, yes, while we are in the edit mode and while we are not in the edit mode. That is the only thing we need to know. Let's say we'll keep a boolean editing equals false, and yes, editing equals false, and let's here add if is key pressed, key, let's say E for edit mode, kind of makes sense, and we'll call the edit mode function which takes in the grid. That is the only thing that it takes, and also editing equals true. We are editing, and here handle cursor while editing. Keep doing this and put this on a separate thread in the edit mode. So std thread update mouse and the state handle cursor as a function and address of the grid, handle thread update mouse, handle cursor grid. That is cool. And here we are not sending a reference, we are sending a pointer to the thing, and here we'll send in whatever is at that grid. And we don't need any OS specific code. Whenever mouse is pressed, yeah, we will have to do some crazy maths inside this if and inside this non-if thing. Yeah, begin drawing, and let's not care about the prediction grid for now. We will just do share, but we also need the shaders and everything in the render grid. So let's put all of that, all those things in the render grid function and not in the main function. Makes sense. Auto bloom and this, both of these things will go in the render grid function. and they need access to the screen height, width, and the screen height, which they can get without these function calls, and that is get screen width and get screen height. And what is GLS version? That is a nice thing. Input all of this here. Okay, and all of this begin drawing and all of that will, is it not in the render grid function? If this is not, then what is in the render grid function? We just have a for loop in the render grid function, which does not look good. Render prediction grid and render grid update help dialog box does not exist here because it is down below. Print grid, where are we using this? We are not using this anywhere. That is fine. Draw help dialog box. That is a maths. Update help dialog box. Let's also keep this, and you can put all of this here. Dialog alpha is now gone because this also needs to be copied. Okay, that is nice. We have the bloom and everything here, and render grid, square height, square width, cell size. All of this has to go. Begin share mode and texture render grid. Yes. No. Okay. Render grid is now cool. We just give it a grid and it renders by putting in all the shaders and everything. So yeah, that is now contained. Did you solve the Minecraft? Nope, I didn't solve the Minecraft problem. My bad. You asked 10 minutes ago. And sit. My mouse is. Okay, yeah, something is wrong with the OBS, at least just on my side, but yeah, here it is cool. Okay. Load shader. So render grid is like self-contained at this point. That is cool. Update help dialog box and everything is there. Right. We can focus. Update map is also there. Handle run puts also there. Render grid, just give that function the grid. Render grid undeclared because we need render grid somewhere else. So we can put rendering related functions somewhere else, right? Like draw help dialog box, update help dialog box, and render grid, render prediction grid, print grid, and everything like this in a separate file, rendering.cpp. And what are the things that are required? Okay, shit. Uh, buffer ls shit. Uh, buffer list shit. Buffer uh, dialogue with variables. Helper.cpp undetermined conditional directive. That is fine. Include render.cpp. Render.cpp not found. Why? Because it is declared here. Okay, that is sad. Move render.cpp into source. cd source and start. Harpoon is empty. Um, okay. If not defined helper, then define helper. And yes, we messed up in the last part of rendering.cpp, which is this endless. This has to go here. While not found. Why render.cpp? Rendering is the name. Okay, it has a like weird condition somewhere. We don't need the thread here, which does make sense. We are not using any thread stuff here. And draw dialog box. Shade, yes, clear background is something also that we have to call. And are we calling it? Nope, we are not calling it. We are not calling clear background. Okay, we will see. If we do face some problem because of that, we will fix that later. Print grid, and that is cool. So what is the problem here now? First of all, yes, Vimtech is not updated. That is nice. Minecraft. Okay, cool. And so there is an error right here. Render grid. Use of undeclared variable render grid. Yes. Include rendering.cpp. Yep. Error is gone. That is nice. And here we have an error. Main.cpp. Redefinition of dialog alpha. Who is redefining dialog alpha? Dialog alpha is there. This is this is the render function, and we just have defined dialog alpha once. Who is redefining dialog alpha? Shit. Shit, someone is redefining dialog alpha. Okay. If not define render, then define render and if now no one would be redefining dialog alpha if someone was. Yeah, no one is redefining dialog alpha, and that look at this. The main function is just 29 lines of code. That is nuts. That is very kind of beautiful. We don't even need game state. We don't even need game state. Yes. Handle inputs, update time, and shit. Yes. Then later on we do have to call the render grid function with the grid. 30 lines of code, and this is the rendering function. That is nice. Render everything which is related to render is here. And what is this? Take grid position. Shit. Just remove that. Why do we have like so many variables? That's cool. Crazy cool. And now handle cursor. Handle cursor. This is the main part. Okay, at least this should work now. Okay, edit function is working, and this is like much better latency than the last one, so that is kind of cool. Now do we see all of this printing stuff? Something is wrong with the render function. Oh, something wrong with the render function. Bloom rectangle and begin drawing, begin texture mode, print everything in the texture mode, then end texture mode. How was this like originally? Source, yes, main.cpp. What is the order of things? Begin drawing, begin texture mode, render grid. Okay, we are rendering grid just after the texture mode, and then end texture mode, begin shader after ending the texture mode, which is what we are doing. So why are we printing all of those crazy things on the terminal? And yes, in the edit mode, whenever we are in the edit mode, if someone if is key pressed, if someone presses key space, let's say, we will just toggle them back. And in the main thing, we will first call the edit mode. Make dot slash and make my game hmm, hmm, edit don't allow shit uh yeah. Update thread, we are creating a thread, and yes, if this key is pressed, break and makes sense. Okay, break and editing equals false, and here update mouse dot join. Yeah, update mouse dot join. And edit mode. Make and run my game. We can add stuff that is nice, like a single line or something. And space, and this runs, and enter for adding random things on the screen. That is nice. We can keep entering random things. There is a lot of stuff, blinding lights. So that's cool. That's cool. We can exit. Window closed successfully. That is also nice. Window did close successfully. 30 lines of code in the main function. Yeah. And here edit mode. Yep. In the edit mode is key pressed, render grid, update handle mouse. Handle mouse will keep updating the mouse position. Okay, everything is cool right now. Now we just have to, yeah, now we will apply the things that we learned yesterday. Examples, not examples, cheat sheet. Delta, not delta time. Get mouse delta. Get mouse delta between frames. Delta in like times. Set mouse position. Get mouse position and get mouse delta. Get mouse position and get mouse delta. Get mouse delta. This is giving us a 2D vector. Let's see. We will get change cell. This function. Yeah. Get mouse position and vector 2 delta equals mouse delta. Get mouse delta, and all of this will not be here. Change cell in this grid that no, let's rename the function from change cell to take cursor pause. So, substitute change cell with mm, get cursor position. Okay, a function to take grid position using mouse and change it to the desired state. Yes. And then delta, and after this we need to do the DAA, digital differential analyzer, and these x and y values, vector 2 current equals, yeah, the whole algorithm that we did yesterday. Current if Location dot x. Uh, yeah, from the last frame, let's see. Delta dot x, space, delta dot y, and a new line. That is all that we are doing here. Yeah, cool. Run update. Yes, cool. And what do we see? We don't see any updatation. Yes, we do see it and some updating. Yeah, so it is how much our mouse has moved. That is cool. That is cool. That is cool. And that is also taking a lot of CPU. We can fix that. Texture shader, texture loaded. Why is this loading texture? Okay, makes sense. This makes sense why we are loading texture this many times. Because whenever we are, because we have moved our texture from the main function into the render grid function, and we want that to be available to every function. Shit. And whenever we are calling the render grid function, which is like 100 times per second, we are creating a new texture 100 times per second, and that is not very good. That makes sense. Okay. And mouse delta gives us the delta of the mouse, so we can calculate where the mouse was and where the mouse is. We can, after that, do our same thing that we did yesterday. So that would be cool. Okay, even though this, the external grid is still, uh, the thread is still running, the external thread, which takes mouse positions. It is still running somehow. Performance scores are like not doing anything. Terminated. Why was the thread still running? This only runs while editing is equal to true. And yes, while editing is equal to true. Editing equals false just in case. Handle inputs. Yes, editing equals true. And call the edit grid function. That is nice. But anyways, why was this misbehaving here? And why am I not in the edit mode? Okay, this is not taking 50% of the CPU. That is not very good. Editing equals true. Okay. Why are we not going into the edit mode here? Why doesn't this like stay in the edit mode? Prediction grid equals to grid. We don't even care about prediction grid right now, at least. Hey, edit. Ah, makes sense. Editing equals true. So yeah, they don't even have to care about if there is a editing mode or not. And we can just edit here right now. Cool. Makes sense. That is cool. Very cool. And also, if is he press quit, then call the quit function in the edit mode, and we know what the delta is doing, so we don't need to print the delta. That is nice. And here we can just do this. Yeah, that is nice. Yeah, and we can also change the FPS whenever we are in the edit mode. That is also cool. Let target FPS, input FPS, and before exiting, we will do set target FPS. Yeah, so we are at a higher FPS here. We need even higher FPS because here we would get like two positions which are very far away, and this was supposed to be circle, not a straight line. Let's make the FPS even higher, then put FPS higher. Okay, game of life exited. Will this help? I guess this should. Not really, really. Okay, why was there a segmentation fault? Object created, we just pressed for quit. So let's not do this. Then in the edit mode, at least. Edit mode, update mouse is keep. Okay, wait, forget. Quit. That is great. The thread is quitting, not this while function. Yeah, window closed successfully. That is nice. Okay, FPS. We are still not getting the positions fast enough. We are not getting the positions fast enough. We are not getting the positions fast enough, and also we are rendering quite a lot of things on the screen. Update map in the render function. Yeah. Load render, auto bloom. Yes. At least we can just put this, and this in a global space, like right here, so that these things are always there. That should help somewhat, I guess. Shit. Yes, that also makes sense. This get screen function, get screen width, and get screen height functions. Load render target. we can go into the main function and say here the target equals to this thing. Does that check out? That does check out. So that is cool. Yes, and this is happening right before rendering mode. So yeah, that should help. Or maybe not. Failed, this file text loaded successfully, and then we got a segmentation fault. Get rectangle load bloom. Let's say all of this is here, but all of this is getting defined here. Bloom, Lewis Bloom. Okay, yes, auto does not make sense when we are not initializing our thing. And so what does this return? This returns a shader. That is it. This returns a shader. And yeah, I guess that's fine. This might work, and yes, this does work. That is cool. That is cool. We are not getting quite a lot of stuff there. Yeah, this is cool. Reset, edit, and a single line, and start. Yo, that is nice. That is nice. Stop. Make another line. Start. So that is cool. That does look cool. And let's say if we what happens. Yes, yeah, right now we are just like kind of experimenting and seeing what happens. What if we create a block of cells? And let's just paint this in. Yeah, we are doing painting. I think this might make cool things. And yes, this shader is actually cool. And I got to know how shaders work a few days ago. And my understanding is that after our grid of pixels is ready, we pass that grid to a function, and that function is called a shader, and that shader function goes through all the pixel values throughout our 2D grid of pixels, and then that function, whatever however it is defined, it changes the pixels in such a way to make the shader available or like visible. Yeah, that is nice. And okay, they are doing something. Let's also create the turtle or the fish. One. I think that is the fish that has. No, that might be the fish. That might be the fish. No, no, shit. I'm messing up. I'm messing up. Yeah, that might be the fish. So that is the fish. That is not the fetch. But yeah, things look cool. Things look cool. Hello, we are making game of life right here, right now. Game of life. And yeah, all of this looks cool. We can stop the function. We can start to edit. We can add cells and we can restart. We can stop and edit, add stuff, restart. That is nice. And the thing that I'm fixing right now is, look at this. When the mouse is moving quickly, we are missing all of these cells in the middle, and that does not look good. And that is what we are going to fix now. Let's let's render grid, edit mode here, handle cursor. Yeah, handle cursor. And this function for handling cursor, this takes the current position of the cursor and updates the cell at which the cursor would be, at which the cursor is currently. So that is nice. And this function is running on a separate thread to make this like fast. Get cursor position. Get cursor position is this function. And here is the place that we have to apply. Get cursor position. Handle cursor. Update cell. We'll have a void function. Update cell. And this will take a vector 2. Yeah, vector 2. Vector 2 copy reference does not matter because it has just two float values. Vector 2 for cursor position and a standard 2D reference to the grid and in state. And this thing will just do this stuff here where we are substituting location by cursor, right? And here is the place that we will apply our digital differential analyzer function. Okay, the game concept is this. Game of Life. This is Game of Life by Mr. John Conway. And if you go to Google, we also have this nice little Easter egg here. And in Game of Life, the rule is there are there is just a grid, a two-dimensional grid of different cells. And at a given time, a cell can either be alive or dead. Right, so a cell can have two states, and then depending on the rules, we calculate from the given state the next state, and the rules are like this. If we have a dead cell right now, this cell which we are depicting by like empty black thing, this is dead. And if a dead cell has three alive neighbors, then in the next iteration this cell will become alive. And if we have at some point, and yes, neighbors are like this. For any given cell, the cell above and below it, and the cells to the like left or right, and also the cells on the diagonals. All of these cells are its neighbors. So in total, a cell has 8 neighbors. 3, 3, 2 neighbors. Yeah, a cell has 8 neighbors. So a dead cell becomes alive if there are three or more neighbors to its, yeah, it has three or more neighbors. And a live cell becomes dead if that cell has more than three neighbors. Yeah, like here, this cell, if you are considering this alive, this has one, two, three, four neighbors. And so in the next iteration of the game, this cell will die. So that is what happens in the game of life. If we have one live cell, shit, okay, why am I not able to edit? Yes, because I'm not calling the function. My bad. Uh, takes in location, the grid, and the state. Here we have a dead cell, uh, all of these live cells, and yeah, the screen is a bit too small to see this, but on the next iteration, this cell right here, this one will become alive because it has this cell as a neighbor, this cell as a neighbor, and also this cell as a neighbor. So this cell will become alive in the next iteration, and so will this one, and that is nice. And this cell will stay alive because it has two neighbors. So if you have two or three neighbors, you stay alive. But this cell, this will die because it has only one neighbor, which is this cell right here, and this one will also die. So if we continue the game from here, this is what we see. We can increase the rate. That is nice, and we can have like more complicated patterns here in Game of Life, like this, something like this. This is a glider. Shit, this is not a glider. This is not a glider. Okay, I messed up in the glider part. I think that is a glider. That is also not a glider. My bad. Uh, that is a glider. Yeah, that is a glider. So this just moves. This glider, it keeps moving. And shit, we also have a glider here. That is nice. We have a glider here, which is moving. And when a glider hits a wall, it becomes a box, which is a stable state. So yeah, this is quite interesting. Kind of data structure based game. Is that is the game concept, and this message got retracted. Nice. Data structure based game. Yes, I mean we do have to use data structure in whatever game we are using, and this is like famous general game. Look, that is a glider right there. We have a glider there, and there is also fish. Game of life. Fish. Fish or something. Game of life. Hallway. Fish. Structure. Turtle. Yeah, this one. Glider. And lightweight spaceship. Okay, this is what they call it. Spaceship. That is nice. Four, three diagonals, and there. Okay, let's add the spaceship. Four, three, one here, and then one here. Look at this. Yes, spaceship is moving from left to right. And you will see when a spaceship hits a wall, it becomes a glider. Now it is a glider. That is cool. That is just crazy cool. Yeah, that is Game of Life. And now we are trying to not optimize, but this thing. When the mouse moves too fast, we are missing cells in the middle. That is what we have to fix. Okay. Yeah, here, vector 2, current, start, or source, target. Spelling of source is wrong. Source and target, and if delta dot x smaller than 0, smaller than 0, then then source dot x. Source equals target, and not source equals location, and source dot x plus equals delta dot x, and source dot y plus equals delta dot y, how much we have moved, and our target would be location where we ended up at. Right, that is nice. And we will also have a mouse delta time duration. We- Or DDA delta, let's keep it at 2 pixels. 2 pixels is nice, or we can keep this in relation to the cell size. That would be nice. Cell size divided by 5. That is around 2. Right, so okay. We have to move from the source to the target. Okay, current equals source, which we can write here, is our source equals target, also equals the same thing. Actually, here, yep, here, target plus equals delta dot x and target dot y plus equals delta dot y, how much we have moved in the y direction. Okay, we have our current cell, next cell, yeah, that is cool. We'll see. Yeah, our while current dot x smaller than or equal to target dot x is within the range, while and also y is within the range. Y is within the range, that would be current dot y is smaller than or equal to maximum of the two, target dot y comma source dot y, and at the same time we also have current dot y as greater than or equal to minimum of the two, target dot y comma source dot y. Okay, while that is true, while that is true, this is what we will do here. Here, yeah, while that is true, is now in which direction do we move? If change is if absolute difference in target dot x minus source dot x is greater than absolute dif greater than or equal to, does not matter, then absolute difference between target dot y minus source dot y, then we will move in the y direction, otherwise we will move in the x direction. Yeah, and here we will also need slope equals target dot y minus, no, shit, we don't need a generic slope like this. We don't need a generic slope like this, like with sines and everything. Absolute difference between target dot y, source dot y divided by target dot x minus source dot x. That is pretty cool. And yep, we have the slope. Our slope, if x is more, then we will move in the y direction. Yes, and the movement in the y direction would be equal to the delta that we defined in the here dd delta. So if current dot y plus equals how much? dda delta, multiply that by, depending on the target y is greater than or equal to. In case of equal to, you would not actually want to go, because that might be in the opposite direction of where you want to go, right? Yeah, that is fine. That is also fine. This is also fine. Source dot y. Yeah, if our target is has a higher value than by 1 or by minus 1. Yeah. Cool. That would be the change in the y direction. What would be the change in the x direction is also something. Yes. dd delta, dda delta is the change in the x direction. What would be the change in the y direction? We have the slope. Slope is y upon x. So double change x double double delta x equals slope. Slope. Shit. Change in y divided by slope. Yeah. Change in y, which would be dda delta divided by slope, because slope is y upon x, and yeah, shit, cool. Now, uh, current dot x plus equals delta x multiplied by if target dot x is greater than or equal to source dot x, which it is. So we are, yeah, no harm in checking in 0, otherwise minus 1 point 0. Current dot x plus equals bda delta into, depending on target dot x greater than or equal to source dot x, and instead of source we should be choosing thinking in terms of uh, current, substitute sources, current. Yeah, if greater, then we want a positive change, otherwise a negative change. Delta y, here we need y, so that is just slope into x. Slope into dd delta. And yes, current dot y plus equals um, delta y multiplied by, depending on if target dot y is greater than or equal to current y, then 1.0 minus, or otherwise we'll subtract if we have to go in the opposite direction. Right, after getting this, we'll call the update self function for all of the current locations. Okay, this should work. This should work. This should work. We will see. Let's go. Okay, this is kind of working. Okay, but why are we seeing stuff here? That is crazy. This is kind of working, but also not. Why are we seeing stuff there? That does not make sense. Also, reset window is key pressed. Reset and random. They need the grid to function. And they also need to know the SpawnX function. That is nice. We'll add this to the handle cursor. Nope, not the handle cursor, but edit mode. And also, hmm, we are seeing like kind of Dragon Ball stuff here. Okay, we are now doing the mathematical calculations correctly. Like, look at this, look at this. Yeah, we are messing up somewhere. Yeah, that does look kind of good. On-way game of life is what we call it. Yeah. Shit. Yeah, so we have to fix some stuff. Hello, I see you already live coding. What do you do? What do what you do? Do is university assignments, or do you define value for yourself? Sorry for bad English. No, that is completely fine. Shit, bro had it coming. Bro saw it coming before. Uh, yeah, this is not university assignment. Like, yeah, and I wonder if the university people, at least in my college, they would know what Conway's game of life is. And yeah, this is not university thing because yeah, I don't. Yeah, college is crazy. College would not help me grow. I cannot rely on college, and I don't think anyone can just believe that college will help them get good. So yeah, this is not college, this is me. Live coding, yes. And trying to get better. And this does look good. This does look good. But we are messing up. We are messing up in the our handle cursor. No. And calculating stuff. Delta. Uh, shit. That I'm stupid. Okay. This has to be minor. And I think now we are good to go. We are not even close to good to go. Shit, what is this? Why is everything just there? Yeah, we are not even close. When we are just moving in the y direction, then we are not seeing anything, literally nothing. Yeah. While current target is smaller than or equal to the target, that is good. And current dot y or current dot y. Let's see with that chain. Okay, why are we seeing stuff here? Why are we making x equal to 0 at point? Like, shit, that does not make sense. And what is that? Why do we see these crazy, strange lines? And that is crazy. Mm. We have, yep, current dot x while smaller than equal to target, and current dot y smaller than equal to target, maximum of the y and greater than or equal to the minimum. That works. I think if we decrease the delta here, let's make this 1 pixel. If y is smaller, then we will move in the direction of y, and if x is smaller, then we will move in that direction. Right. Shit. No, no. The one that is larger, that is the one in which we make our movement. And we can make this again equal to cell size divided by 5.0. Okay, let's see. And what do we have? Okay, this is kind of good, but why do we have that stuff on the left? Okay, nothing is getting updated now. Game is stuck. Game is stuck. Okay, shit. And this is taking 100% of the GPU somehow. Somehow. Stop the game. Shit, don't hate the player, hate the game. Ah, meaning you're getting like short circuited, I guess. Stop. Stats. My game. Stop the game. While at least one is within the range. X, either X or Y, at least one is within the range. Yeah, at least one is within the range. Yes. I guess the cells are a bit too small. Let's change the cell size to be 15. Yep, let's do that. And rows and columns would be 70. Yeah, shit. When X is very small, Y is very small, X is very big. The change in X is very big, and the change in Y is small. And I guess delta Y is approximately equal to 0. And therefore, we are not moving in the Y direction, and hence this absurdity. We are not exiting out of the thread which is taking cursor position. Makes sense, kind of. If you make this and then this should work. Yep. At least we are not freezing. That is nice. Game of life, yes. This is what we have. Game of life. 70 70 row, let's say 50. And shit, this might mess up. Yeah, that does mess things up. Okay. Yeah, cool. We have to keep the things equal to each other. Hmm. That is not very good. That is not very good. Okay, shit, let's make everything go, but how would that be? Let's make a square in the middle. Okay, why do we have a line there? Why do we have a line there? Because our major motion is in the y direction and we are taking one step in the y direction, and the next x direction that we land on is too much absurd. Bool in is in. And yeah, vector 2 reference current, vector 2 reference target, vector 2 current target, and source is in current target source. And here this has to be true, like both of these conditions have to be true, and is in here before calling this. If is in current target, and source. Okay, shit. Okay, that, yes, we are still seeing those crazy things, but this is much better. This is much better than anything. Shit, yes, that is cool. That's cool. Let's increase the size, grid size. 70, 70, 100, 100. Let's go and decrease the cell size. And we will move minutely. Yeah, DDA delta would be like 1 pixel. We will move forward by 1 pixel. How is that? Okay, lines. Lines is what we see. Lines is what. 2 pixels. We still see lines. This is because of circle. And if we are not moving in a line motion, everything else is pretty cool. If we are moving slowly, so that is nice. Let's make this 5 pixel. We're still seeing lines, but yeah, this is kind of following. Now we will have to do some stuff here. Yeah, I guess where, yes, hello, why is there actors at the, yeah, now it is fixed. I don't know why that was happening. It is still not able to track all cells. It is Still not able to track all cells. There are many methods for making lines in Raylib. Are those of no use in your project? Okay, we can make a line, but that is not the main goal. Main goal is to know what cells are on a given line. There is a simple and shit, you do know about these things. That is crazy. That is crazy. But, yeah, there are these functions, draw line, which takes the starting position and the ending position, which we can calculate and does work with. But this is not what we want. This is not what we want. We do not want to create a line from the starting to the ending point. We need to know if this thing is in a grid, which cells are on that line. And for that, we are moving from the source towards the destination, small steps, and we are checking is what is the state of this, where is this cell, where in which cell is this point, and then here in which cell is this point, and then here in which cell is this point, and so on, so on, so on, so on, so on. Yeah, like that. Okay. If the cell size and the delta, which is the distance that we are moving in each step, if they are same, what would happen then? Let's see. That is quite a bit of movement. It is like throwing lines away. If we just move 1 pixel, that also gives us the same thing. If we move like 20 pixels, wait, that is too much movement. One is nice, and we'll do this at the start of the loop. Yeah, we are still not getting the positions fast enough. How does this thing happen in production? I mean, here on Xkildraw, we are not seeing any crazy stuff. We are seeing a smooth line. So how is Xkildraw doing this? So we cannot keep the start and the endpoint really small, so we can track all the cells. We are keeping that. Cell size is 10 pixels, and we are moving by forward by 1 pixel. So that should be good. But the thing is, if I'm creating a circle, and let's by red depict the mouse coordinates that I'm getting. I'm getting here, the position here, then the position at this point. And so we are creating a straight line instead of this curved line, and then position from here, and then position from here. So yeah, the distance between these close points is quite a bit much. Why is that? We can increase the frame rate if we want to input frame rate. I don't know, 400 FPS. That should help somehow, or maybe not. Shit, even in straight motion, we are not seeing stuff. Yeah, but what I do know is it is some iteration of this DDA algorithm that we have implemented that is used here, because polling is not the way. Polling, getting the mouse position quickly is not the way, because we did try using polling with the system calls for getting cursor position, and that was also not fast enough. And yes, this function for updating the thread, updating the cells which have been edited, it is running on a separate thread. It is running. Wait, maybe we don't have to run this on a separate thread. Handle cursor, if we handle cursor, pass in the grid. And no, okay, share it. Now we don't see anything. That is crazy. Mouse delta. Yep. When we use delta, what do we actually get? Give us not cheat sheet. Yes, ChatGPT is fine. And really, when you use mouse delta, you get the change in mouse position since the previous frame. That is how much the mouse has moved horizontally and vertically between the last frames and the current one. Here is what that means. If you think of the mouse's position as a point on the screen, get mouse delta gets you delta, that is now minus the previous. So to get the previous x, I would have to subtract. Okay, shit. Location, get mouse delta and vector 2 pref equals location and pref dot x minus equal delta dot x and pref dot y minus equal delta dot y. And here, if pref dot x is smaller than or equal to location dot x, don't do this, don't do this. Here we'll say, yeah, source would be previous, and let's change the name location, substitute location to current, and current is already here. Okay, sure. Substitute location with now. Now, yes, now, and now, with previous smaller than now, then source would be previous and target would be now, and otherwise source would be now and target would be previous. Delta is 1, and let's put this back inside a loop inside, yeah, inside like a thread. While editing, keep doing this stuff. Okay, that does make sense. We are getting a pointer, and here also we are getting a pointer. Here we'll send in the address on the grid. We won't even send in the address here. We will say thread, cursor thread, and function is handle cursor and address of the grid. And here, after making editing equals to false, we'll say join. Shit, okay, that is much better. That is actually beautiful. That is much better than before. Shit, that is actually working pretty good. This is pretty cool. This is actually cool. Look at this. That is cool. Shit, that is goggles. That is actually cool. Conway's game of life. Shit. Reset. Shit, I can do the instead of Excel draw from now on. I guess we can also use this Conway. Yeah, Conway game and start. Let's go. That is cool. That is cool and good. Let's 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 do some more stuff. So size will be 5 and let's increase the precision of the things. Yeah, that is rather convenient, I'd say. That is cool. Let's increase the precision a bit more and say cell size is 2 pixels, but in that case, you will have to make delta would be just cell size divided by 5.0. Let's see if the computer can handle it. So that is almost crazy. Yes, margin also has to be accordingly. Cell size divided by 3.0 and nothing is giving us error, but we do have a warning here, which is fine. And let's increase these. Ah, cool. That is pretty good. Let's increase the number of cells and rows even more. See, what do we have? Yeah, that is, I guess, a bit too much. Yeah, My computer will fall apart. Yeah, that is a bit too much. That is a bit too much moving things. Yeah, now it does work nice, but still, this is not very good. But yeah, this is much better than before. That is, yeah, this is lagging behind quite a bit. And if we start the game, yeah, that is too many cells. That is too many cells for a simple game to handle. That is too many cells because we have now 500 by 500 things, which is 10 to the power 4, and this is happening. We can reduce the FPS. Shit. This is 10 to the power 6. We can reduce the FPS. Let's say FPS is 10 FPS is fine for our purposes. Shit, FPS in the edit mode is quite a bit. That is working. That's nice. The size is 3 and let's do this 3 by 3 and that is nice. Let's yeah make this normal 100 by 100. Say 5 is 5 and shit. Uh-huh. That is that is something. The size is 10 and we have a normal grid. That is pretty cool. But why do we have like these smaller divisions within a singular cell? I guess because margin is now not very cool. Shit. Yeah, margin is not very margin. Let's fix the margin. And I guess this is how it was before. Should we, at least for straight lines, this is cool. We are not lagging anything for straight lines at least. So that is cool. That is a good achievement. Now we have to fix this for curved lines. This is pretty cool. Let's reset and let's make a straight line down the middle. Shit. 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 And yo, that is good. That is good. That is functional. That is actually good. And now I have to merge back my friend's code with this code. And shit, I was working on the main branch. Which is fine, which is fine, which is fine, which is fine. Yeah, it is fine. Working on the main branch is fine. I can force push origin main. Let's git push force origin main. And now I have to see how my friend was handling the other logic. Yeah, let's see, let's see. So here render grid if game state is 2, then just on top we are rendering grid always, but we are only rendering prediction grid when this thing in the edit mode. That is doable. That is very, very doable. Edit mode, render grid, and then prediction render red grid. No matching function called to render prediction grid. That is true because here we'll do auto grid equal grid and quit, quit, and yes, this handle cursor will also take prediction grid. Mm, this handle cursor will also take in prediction grid, and can we just pass in the prediction grid also here as a second argument, or do we have to use a structure to pass in stuff, two parameters to a thread running function? And whenever mouse is clicked, whenever there is a change, we will say go to prediction grid, make it equal to go to grid, like after making the change. And render prediction grid, make them equal to each other. We also have to update prediction grid while we are here, and also it's now give that here. That does work out, I guess. Yeah, let's see if we are getting error or not. We are not getting any error, so that is nice. That is actually nice. That is actually nice. Let's okay, before this, I will make a comment. Uh, yeah, and get ignored. Shit. My game. And what else is there? RM, RF, W, it is. RM, RF, source, W. Get a status that is not here anymore. And CMake, my game, CMake file, C, files, slash my game, everything related to my game. Who is even calling this thing my game? Get status. Okay, that is nice. Get ignore. We have made changes to get ignored, and CMake file, source, helper, and variable. We have made changes to everything. Get add, get commit message would be added digital differential analyzer, right? And this was on the main branch. Yeah, that was on the main branch. Shit, my bad. Right, okay. And update if we are here. So not rendering variables. Edit mode. Yes, in edit mode. Render grid and shit, where is the update map function? It is downtrodden. Put it at the top. This will take one. Prediction grid, which we will define here from the main grid, and prediction grid, and that will be our second argument parameter vector and pointer to the prediction grid. And whenever this happens, then say prediction grid equals grid, and same thing here. Okay, nice. After rendering the main grid, we will render prediction grid. We can run the game. Okay, prediction grid is not working right now. Why? Update map. Yes, render grid and then also render prediction grid. standard struct grids vector pointer grid and std vector std vector and prediction grid. And let's say this function, instead of taking all of this stuff, takes in this data structure called grid. And instead of uh, handling grids, here we have grids dot grid. Shit, yes, these things. Can we have a reference inside our structure? I think we can have a reference. Let's see, let's see. Grids dot prediction grid equals grids dot grid, and here also grids dot grid. Take this line, and here we have to change what we are passing into our thread. Handle cursor function and grids. First is the grid, second is the prediction grid. And here, let's see. It does seem to be working, but we are not seeing any predictions, which is a shame. We are not seeing any predictions being rendered onto the screen, and I don't know. Not yet, not right now. Yeah, I was like, okay, to do something else and take a break. Shit, my phone is going to die. And yeah, so now what we are trying to do is hard to explain and easier to show if I am able to do this. Okay, this is still lagging behind. I guess the reason is rounded point 3 and DDA delta. Where is DDA delta? Yeah, DDA delta. Cell size divided by 5, which is 9, which is like 2 cells. If we make this thing divided by 2.0, how much are we going to move? This is much better, but we are losing precision. Yeah, this is also fine. This is also fine. But still, yeah, we are losing precision. Why is this thing lagging? Is this lag the same in Excel draw? No, 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 no. In Excel draw, we have like the thing following. Yeah, shit, yep. There is no lag. The line is following the cursor. So that is nice. I don't know how they do this. This is amazing. It's like, yeah, shit, how they do this, I don't know. How are they able to get the mouse position like this? And they are like able to maintain the curves also. Look at this. If we make this too small, we can actually see like some strange things happen, right? Yes, they are making very small circles. Yeah, they are making very small circles. at these places, and then they are kind of smoothing out the circles, like if yeah, so something is happening here, something is strange, like it is shaking or something. Yes, look at that. Yeah, so my hypothesis is they are making circles and then they have a second script, asynchronous, which is should SOS help me, which is smoothing out stuff. Blackboard. No, this is game of life. Yeah, this is game of life. It's not a blackboard. Yeah, game of life, which is a classic thing by Mr. John Conway. Shit, I might have just messed up his name. Yeah, John Conway. John H. Conway. Yeah, that is the guy, and he died in COVID-19. That is sad. Yeah, this is the game of life. He created the game of life with his colleagues. Rendering. Yep. Um, Render grid. I is columns. J is rows. Input FPS. Let's make this 60. No, yeah. What do we get now? Okay, so this is nah, this is still not very closely following our mouse, and still we are not getting as much precision as we would like to have. Edit mode. No, no, no. Yeah. Grid status. We have made changes to helper and variables. That is fine. Now the prediction thing. Yeah, fix the prediction thing. The game of life. Yo, hello. The game of life is yeah created by Mr. John Conway, and in this we have a grid of cells, a 2D grid of cells, and a singular cell can have two states. One is alive state, or given cell could be dead, and whatever the current state is for our grid, by which we mean which cells are alive, which cells are dead, and there is no other state, either a cell is alive or it is dead. And given that if there is a live cell which has the neighbors, for any given cell there are 8 neighbors, up, down, left, right, and in the diagonals. And if a live cell has one neighbor or more than 3 neighbors, like 1 or less than 1, or 3 or greater than 3, greater than 3, less than equal to 4, uh, uh, if neighbors, shit. If for a live cell neighbors is smaller than or equal to 1, or if the neighbors are greater than 3, then this live cell will become a dead cell in the next iteration. And if we have a dead cell and this dead cell has neighbors more than or equal to 2, I think. Yes, more than, not equal to, just more than 2. then this dead cell will become alive in the next iteration. And here, all of these cells which are bright, they are alive. And in the next iteration, yeah, depending on the rules, this is what happens. We are getting new states depending on the rules. I can increase the rate at which this is getting updated. So that is nice. That is nice. That is cool. And also, shit, the FPS here is fine, 60. But why do we have 10 here? Yeah, this is running quite fast now. And here, this thing is a glider, and this keeps moving forward in our direction. We can actually make a glider here. Remove everything. Let's make a glider, or not a glider. Let's make a turtle or a fish, whatever you want to call it. Uh, 3, 4, like this, and then no, no, I messed up somewhere. Shit, no, no. Shit, I messed up. This is alive. This is alive. Shit, how do we make a fish? I forgot. Wait, no, I don't want to look it up. 1, 2, 3, and 1, 2, 3 here. This is certainly not a fish, I suppose. This might be a fish. Let's see. Shit, that is a fish. That is how we make a fish. So yes, this fish moves forward in the direction, and when it hits a wall, the fish becomes a glider. That is crazy. And when the glider hits the wall, it comes to a stable state and becomes a square. So that is nice. That is the game of life. Yes, fish, turtle, we have different things. And not just this, in game of life, shit, game of life, in game of life. We can have game of life inside game of life. Recursion. Shit, yesterday I got copyright when I was playing a video. Okay. So yes, now they are zooming out. Look at this. That is game of life. And game of life is Turing complete. So you, theoretically speaking, you can create GTA 5 in game of life if you want to. And this is game of life inside game of life. That is just crazy. Yes, we have game of life inside game of life. That is cool. Crazy cool. And someone sat down and made this whole thing, which is crazy. And shit, this is a turtle. Uh, the fish. This is a fish. This is a fish, which is moving from right to left. Yes, game of life in game of life. That is crazy. Let's make a fish once more. Yeah, fish. This just looks very cool. And that is a glider. And let's reduce this a little bit and run. Okay, I cannot see the bottom still. 70, 70. Yes, and the bottom is visible. Let's make a glider here. Right, cool. And we'll make a glider here which moves towards the bottom. 1, 2, 3. 1 and 1. Okay, they will fight. Yo, let's go. And they reached stability. And we can stop and we can make one more glider come towards them from here. Let's go. Shit, let's send in one more from here. Shit, they're going to fight. Shit, that glider destroyed them. Okay, let's send one more glider from here. Okay, and that is nice. Okay, let's make a straight line, not so straight. And this is a nice pattern. This creates a nice thing. Look at this. Okay, this is too fast. This is a bit too fast to admire the beauty. And yeah, a straight line. Shit. Yo, that is cool. That is squares. That is game of life. NASA computer to make it. Shit. Boom. Yes, for the game of life in game of life. Yes, that is crazy. And still, I don't get how Excalibur is getting this. This is too much precision, and the line is not lagging behind at all. And this is happening in the browser. So they are doing some crazy engineering. Yes, that is crazy. That is crazy. That is crazy. I will have to look it up how they are doing this. Anyways, about the prediction system. Harpoon. Yeah, rendering. Shit. Makes sense. Makes sense. My bad. That does make sense. Okay. Copy. And we'll just take this for loop and replace this one. I think now we should be cool. Shit. Okay, that is too much stuff happening. Shit. Virus is spreading. FPS is 60. FPS is not too much. FPS is 60. FPS is not too much. Why do we see that flicker? That does make sense. That does make sense. That... Okay. Um, yes, okay. Render prediction grid will have its own loop and also the normal, yeah, also the normal loop. And in this, we'll change, substitute grid with prediction grid, and prediction grid is the second argument. Reference, and yeah, cool. And not just here in edit mode, we'll bring this, share. That is nice. That is nice. So this is telling us if we go forward with what we have here, so that is like predicting what would happen in the future, this part. And that is cool. That is yeah, that looks cool. Look at that. And whenever I make a change, the prediction starts from scratch. So that is cool. That is actually cool. Let's bring this up to its original 100 by 100 size. Yeah, that is cool. That is cool. So yes, this is working. Share, what is this? Cadmial Rome spline. Excel Draw uses this for smooth lines. Also, Raylib has draw lines Bezier, which can be used for something similar. Okay, what is this? Centripetal Cadmial Rome spline. Okay, in computer graphics, the centripetal Catmull Rome spline is a variant of this one originally formulated by this person and this person, which can be evaluated, using a recursive algorithm used by Berry and Goldman Sachs. It is a type of interpolating spline, a curve that goes through its control points defined by 4 points. Okay, so we are working with 2 points. They will be working with 4 points. Hmm, that is too much work. That is too much work. We are working with. Mm, they are working with 4 points. 4 points is quite a bit long. And actually, draw has this function draw line bezier. Not actually draw, raylib.com slash cheat sheet. This one. Uh-huh. This takes in a start position, end position, float thickness, and draw line segment cubic Bezier in out interpolation. Cubic Bezier, should they have a actual website? Wait, what is this? Okay, that is something. Cubic Bezier, that is some function somewhere. But yeah, this is cool. And can we uh, make some change here? I can increase the FPS while taking the input. 120 is kind of nice. That is like fungus spreading everywhere. That is cool. That is cool. Enter random. Ah, shit. Okay, okay, okay. Shit. I did mess up. I did mess up. I did mess up. I did mess up. Whenever we clear the grid or we do something else, we would have to update the prediction grid also. Okay. So therefore, reset random, and this will return a bool, and change equals false, and if this, then change equals true, and here also the same thing, and return change, and this is being called in the edit function. Yes, in the edit function. If this, then prediction grid equals the main grid. So yeah, now we see the prediction grid. That is too much stuff on the screen. Remove, add random stuff, remove, add stuff. Yes, that is fully working. Let's add a commit. Prediction grid working again because I broke it. And now handle draw helping dialog box. Yes. Controls is okay. Mouse right, mouse left click to add a cell, and press the right click to kill the cell, and space. What is start, pause, and resume? Pause, resume. Let's say uh, E for edit mode, R to clear grid, R to clear grid. Cool. And up down to, yeah, and enter. Yeah, cool. That also looks nice. You have it right here. Left to add cells, space to pause, resume, pause. Okay, shit, this is not resuming or pausing on a space. So handle inputs, that is the function. handle run inputs while we are running, and whenever wait, this is not checking for a space. This is not checking whether space is pressed or not. Who is checking for a space then? Running P for I don't know what the hell. Pause. Running equals not running. Okay. Space to run. Shit. Ah, how do we know that we entered this function from the edit function? If we do, then yeah. If he pressed quit, then quit, update grid, and also is key pressed quit, and for random and space uh, C to continue, edit mode, N in normal mode, but these things have to be like close to each other. E to edit mode makes sense. R for random, space for space, and let's say D to continue somehow. Like not running mode, run mode, and text X and text Y plus 20. Shit. This by the way is genius. Shit, this is genius. This is genius. This just works out now. Okay, this is going a bit out of the way. Assigned height into border rectangle. Draw rectangle rounded internal and external. Dialogue roundness, box box is there, right there. uh Dialogue width. Okay, we have to increase the dialog box width. Height, let's see, 20. Yeah, that is nice, that is nice, that works. C D shit D for run mode. In edit mode, if D is pressed, then we will go back to the main thing. That is nice, that is nice, and yeah, that is nice. Should I guess that would be it for today. I don't think. Wait, shit. Oh, contest. The like the tutorials is be completed. Share. Okay, the contest thing. And that is cool. Yesterday's contest. I guess I will give a virtual contest today. I mean, yes, of the stream. That would be nice for yesterday's contest. A single guy created the whole contest. That is nice. And yep, that would be it for the today's stream. Yeah, we did Game of Life. We applied digital differential analyzer to our game, and we are getting precision. We are not getting curves, but at least we are able to mark all the cells on a straight line. So that is good enough. And yeah, that is cool. And that would be it for today. And thank you for being here. Bye.